In example number 2, y equals negative 1/4 x squared. First thing we have is a vertical stretch. And if we look at what our a value is 1/4, negative 1/4. So we have a vertical stretch by a factor of 1/4. And that's about the x-axis. Secondly, we have a reflection because it's negative, a reflection in the x-axis as well. With number 2, we need to express our equation as in the form of y is equal to a x plus p plus q squared. And in order to do that, I got to get this 1/3 over to the other side. So if I were to multiply it by 3, it's going to balance it out on this side of my equation. So I would have y is equal to 3x plus 6 squared. Now this is the equation that I'm going to look at and compare to x squared. So if I do that, then I'm going to have a vertical stretch by a factor of 3 this time, by a factor of 3 about the x-axis. And I'm also going to have a horizontal translation, 6 units to the left. In class example number 3, I have 3 transformations that are applied in this order to y equals x squared. So first of all, I have a reflection in the x-axis. So I go from y is equal to x squared to y is equal to negative x squared. Next, I have a vertical stretch by a factor of 1/3. So I go from y is equal to negative x squared to y is equal to negative 1/3 x squared. Next, I have a translation of 7 units to the right. So from y is equal to negative 1/3 x squared, I go to y is equal to negative 1/3. To the right, that was going to be x minus 7 squared. And so this is going to be my new equation. And we're also told that at the end of the 3 transformation, the point 1 and t is on the resulting graph. So my y value we're going to call t. But before we do that, we want to state the vertex of the final graph. And so I didn't move vertically at all, which means my vertex is now going to be at 7 and 0 instead of 0 and 0. Now, in order to find the value of t, I know that this coordinate is on the graph. So where my equation was y is equal to negative 1/3 x minus 7 squared, if I substitute my values or this coordinate 1 and t into my graph, we're going to be left with t is equal to negative 1/3 1 minus 7 squared. If I simplify what I have in the brackets, this is going to be t is equal to negative 1/3 times negative 6 squared. And for further simplification, I end up with negative 6 squared is 6 times 6, or 36. And 36 times negative 1/3, t is going to equal negative 12. And our last question, we're just looking at these equations, and we're assuming that these are transformations based off of y equals x squared. So first of all, the vertex of something like this is going to be my p value, which would be negative 3, and my q value, which is negative 4. Because this is negative, it has a maximum value, and it has a maximum value equal to q of negative 4. And our axis of symmetry is equal to our p value, so x is equal to negative 3. Our domain, if we were to plot this, it's going to have x values that are element of real numbers and a range of my y value, because it's a maximum value, has to be less than or equal to negative 4. And with this next function, y is equal to 3 times x minus 9 squared. The vertex, again, is my p value, my q value, and so positive 9 this time and 0. it's opening upwards, so it has a minimum value, and this minimum value is going to be at 0 because there is no q value of 0, and my axis of symmetry is equal to my p-value of 9. Again, we have an x as an element of real numbers, so all real numbers of L will work here. However, with our range, y has to this time be greater than or equal to 0, since my minimum value is 0.